Hello and welcome to my talk about our vision paper towards a benchmark for software resource efficiency. The load on data centers is increasing. As more and more applications are moved to the cloud, more and more users are using the applications that are provided by cloud providers, and also more and more devices, like Internet of Things devices, are communicating with the cloud and using it as a backend. This leads to an increase of load on the data centers, and therefore data centers are growing in numbers and in size. And by this day, data centers consume about 263 terawatt hours of energy every year and are estimated to rise to about 1,137 terawatt hours until the year 2030. But luckily, cloud data centers can be made more efficient by, for example, intelligently placing or consolidating services on different servers, making the service using more resources, giving it more resources, or deploying it on multiple machines. Also, one could minimize the resources through technologies like autoscaling while satisfying performance demands, deploying more instances of the same software to handle more load. The hardware can also be made more efficient through technologies like DVFS, which is dynamic voltage and frequency scaling, but also different C states to disable or switch off different parts of the hardware. But in the end, it's the software that controls the hardware, and the technological advances that I mentioned already cannot fully compensate the growth of the data centers. And also it is known that different but functionally identical software can have a different energy efficiency while the performance only changes marginally. So our idea is to increase energy efficiency and also the resource usage of software in the cloud data centers is a software resource efficiency benchmark. This should have three goals. First, software vendors should get an understanding of the resource consumption of their software. Second, software buyers should be able to compare their software or software they want to buy from different vendors according to their resource efficiency. And third, spark competition between the software vendors to make their software more resource efficient. To achieve our three goals, we have to overcome some challenges, and we identified, in our opinion, the main three challenges to do so. The first one is, how can we describe the resource demand of software? Currently, to the best of our knowledge, there's no accepted standard that expresses the resource demand of software. There are resource profiles that describe a software system's resource demand, but they are dependent on the corresponding workload. Other options are the minimum hardware requirements, but they are typically away for client-side software, and our benchmark is focused on cloud data center software. There's also capacity planning, which is an accepted norm to describe resource demand of software, but only describes the implication of a specific workload on software and not the actual software resource demand. And our idea is to make the resource demand more transparent before runtime during the purchasing decision. The second challenge is how to specify and standardize workloads. As we have seen, first approaches to describe the resource demand exist, especially for individual transactions, but they are not comparable without, at the same time, standardizing the workloads. Now, workloads can be standardized, but only to a certain degree, and that is depending on the application type, because different application types have different functionalities, and a standardized workload for application A, like an ERP system, will not work for a different application type like a CRM system. Now this also includes the behavior models, the behavior mix, and the workload intensity. And this is where software vendors need to agree on a standard workload model for each application type to make resource demand comparable among different vendors. The third challenge is, what are possible incentives to increase awareness and acceptance? Now we need to increase the awareness for all stakeholders. That means for software buyers, they need to know about our benchmark, they need to know where to find results and how to compare them. The operators of software need to deploy the most resource efficient software, and providers could incentivize operators and software buyers to only deploy resource efficient software. But a solely technical solution might not solve this issue. And an idea is to adapt working approaches from incentive-based mechanisms like the Energy Star logo or motivate users for a sustainable future. To address the mentioned challenges, we will take a look at the different formats and the vision in general of our benchmark. First, we start with the three general input and output descriptions, which is the workload specification format, the execution environment description format, and the software resource demand description format, which you can see on the right side. These are provided collaboratively with all stakeholders involved to find a general description for each of these artifacts. In case of the workload specification format and execution environment description format, first we have an abstract description and then a more specific description for each particular software type. The more specific versions are defined for each software type together with the vendors. And the output from the benchmark is a software resource demand description format in the generalized form. The vendor-specific instances of these descriptions, the workload description and the execution environment description, will be put in the execution engine, which deploys the application in the cloud and executes the workload. The measurement adapter that we can see in between uses various tools to collect all the measurement data and sends it back to the execution engine, which combines all the data into the measurement results and the resource demand description instance. This resource demand description instance is then sent to the central storage repository, which is hosted publicly to allow comparison of results. Our vision of the benchmarks will be developed collaboratively with other stakeholders, and in the future we hope to achieve a similar impact as the Spec Power SSJ 2008, which increased the server energy efficiency by 19 times on average. By publicly hosting the results, we create transparency for all parties involved. We also want to continuously share the results with different communities to increase awareness for the benchmark itself and steer the development of software towards more resource-efficient software in the future. Yet, there are some limitations to our benchmark. One is the limited expression from hardware. We want to look at the resource efficiency of software itself. That means that we have to reduce the influence of hardware as much as possible, but abstracting the hard and the software from each other can be very difficult or might not be entirely possible. The second one is the impact of resource efficiency on the operational costs. So workload standardization and comparability do not guarantee an efficient operation, meaning that the operator who deploys the software can still deploy it in a manner that it uses more resources than it should be. And the third one is custom-built software artifacts and customer-specific features. We aim for a very general benchmark that is applicable for most applications. Not all features or custom-built software can be considered. To conclude my presentation, we have a growing load on data centers, and the technological advances cannot fully compensate this growth in data center load. So our idea is to design and develop a software resource efficiency benchmark that in turn will also reduce energy consumption and has three main goals. First, software vendors should get an understanding of the resource consumption of their software. Software buyers should be able to compare software from different vendors according to the resource efficiency. And third, spark a competition between the software vendors to make the software more resource efficient. Thank you for your attention.